how long does it take actually to define what those high-level operations actually are? So it's easy to draw and give an example, but then start to think about, in all possible cases, what should actually happen.
That's a good question. I usually find it doesn't actually take too long to draw up, if you sit down and think about it. It's usually best after 2 or 3 days with no sleep. If you just sit down and draw up a list of everything you could think of, all the ramifications, it doesn't take long, an hour or two. And then you just sit and think on it, you implement it, and then you give it to a bunch of people that probably ought not ever program. And then you end up with a list that's about 3 times as long, and then you go from there. I will admit, I find as an implementation strategy saying you can do this, but you can't, but rather than specifying the things that aren't allowed, I only specify the things that are, and if it's not allowed, it's forbidden. Because that lets me later on, I find it much easier to remove constraints later than it is to add them, because it turned out that I shouldn't have let you do something. Or I didn't tell you that you couldn't, so you did, and now I'm stuck with it. So, yes?
It's actually, it's fun and refreshing to see someone thinking about cool things that most Java and C# and so on VMs would never contemplate doing. The converse of that is that among the things that's hard for the style of VM that you're talking about to support are those things you want the VM to promise to never do.
Like what?
Exceed the set of resources.
Oh, actually, as far as that goes, that's actually easy. It turns out that it's easy if you're willing to pay the cost. Now, obviously, you have to take a look at it. Where are you coming from to begin with? Obviously, I'm coming from well, not obviously, but I am coming from a scripting language background where the source is generally trusted, unless it's and you normally aren't. I'm not worried normally about the sort of attacks and the sort of issues that folks doing secure JVM work are, which is nice. I like not having to worry about security. But for something like that, what we've decided to do is actually put in we've pulled security out, and we've pulled quotas out. So quotas and security are 2 separate things. And for example, if you want to run Parrot and you say your particular interpreter only gets 3 megabytes of memory, we kick in the quota-enabled functions. And every time you allocate memory, we check your quotas, and if you exceed it, you blow it. We throw an exception, and you either handle it or you kill, depending on how fatal it is. And I will be right up front, I'm not a security and quotas guy. And so everyone who does security says, don't even try making it up, you will screw it up horribly and you'll never be able to fix it. So we've basically just stolen the VMS security and quotas and privilege model because it seems to work out okay, and everyone I've talked to says it doesn't suck. So what more can you hope for from software? But it's outside of this. In addition, that's the case where you want, you necessarily want to be able to spawn up 10 million threads, well, only if you've got the privilege or the quota to do so and stuff like that. But it's security and quotas are orthogonal to this. Ooh, I get to use that word twice in a day. Anyone else? Or
any more questions here? Michael, you want to?
Maybe just a remark. What you call quantum superposition is, as far as I understand, not quantum superposition.
No, it's not.
It's non-deterministic in the sense of logic languages.
Yeah, it's not truly quantum. It's just a junction of, it's just a superposition of values, but it's not quantum as such. Although I have, on more than one occasion, actually threatened to make it truly random, where it actually does not look like it's got 8 values. It looks like it got 1, but which one you get depends on when you look. Which would be quantum error, I suppose.
Is that what they want?
When people start talking about this, I don't necessarily care what they want. It's like, you asked for what? It's like, okay, you're going to get it.
I think you forgot that you're supposed to add the sine waves of probabilities of the various things and put out the output of that.
I could use the GC as a support, as a source of entropy.
Well, I would just implement it by hooking onto dev lambda.
Well, the nice thing about actually the quantum superposition is it makes implementing quantum intercal a lot easier. And if you think about it, intercal is one of the very few, is actually the only language I know that's already is already set up by its base language for being a quantum language, because it's got the come from statement. So if you have multiple come froms, you just spawn off multiple threads, and which the actual state of your program is depends on which one finishes first. And that's usually the part where people start looking at me weird and backing slowly away. So I should probably sit down.
Just wanted to sort of dispute the notion that scripting languages don't care about security. I mean, that's sort of that's a use case for Python that it doesn't support well, that users complain about a lot. That it's used involved in some sort of extending or embedding application where they have part of the runtime in Python, part of the runtime in another language, and they want to load untrusted code.
Actually, and it's something we're taking very seriously with Parrot, but we pulled the security model out to be a separate thing. And we've got people going, well, I'd love to have you as my runtime engine so I can embed, I can use Perl or Python to write scripts for my MUD or my online game, except that my users are all a bunch of, overactive, 12-year-olds with sociopathic tendencies. So, but. It is a spot where, unfortunately, the scripting languages could do more. So we will. Damn it.
Ready to wrap it up?
Yes.